looking at the projectile and dropped objects. And there's still a lot to be done in this chapter, so there's plenty of content to continue. And so I was thinking about skipping chapter 3.7, quadratic inequalities, but I know for a fact that's in the ACE Math 1 quarter 2 content, and I don't want to not, cover it. So I'm just moving the text back. It's fine. That's okay. And with those these new required meetings once a month, I have to miss class for these required meetings. So the schedule is gonna change every now and then, and that's okay.
So you plug in 800 billion for A?
Yeah.
Wait,
that's a big number.
Well, I'll have to put the extra billion, do I?
100.
Oh.
Yeah, because the function is in billions, you just put the 800 in.
Okay, earlier.
I don't know how many zeros I had.
I like zero, but I right.
Question, because it has to do with energy and electricity and consumerism. I love all that talk. So the A of nuclear energy generated for consumer use in the U.S. is modeled by this function, and this is since 1980. In what year did the amount of nuclear energy generated reach 800 billion kilowatt hours?
Things only become more convinced that you just don't like teaching math and would rather do something
like science, but it is math, so I'm okay. Application. You too, Desmond? You like science?
What do you think? I love science.
Applying it and talking about like where the math is used. So our government uses models like this when it's talking about clean energy, and it's justifying holding high standards to automobile factories, and all of our cars now have these weird on and off. Whenever you're any of your cars, when you're at the stoplight, it turns off and turns back on.
Oh, the energy saver.
The energy saver, and that's coming from models like this. And the world and the government accepts nuclear energy as a clean energy source.
My dream job to do is mainly science, but I never math. I want to get into veterinary health. That's where the artists. And then make it into so much.
Tomorrow you can go down to the office. Tomorrow. She said you'll be back, so just leave it.
About everything.
Yeah, different formulas, same step. It's not the launch or dropped object, like this isn't a negative 16. We're going to use the same process, but this is the equation we're doing it with. So I'm putting in the 800 for the A. And we're solving for time. How many years after 1980 did we start generating all of this nuclear energy? Very controversial. Correct. You want to set this equal to 0 so you can use the quadratic formula. And this is obviously very calculator intensive with these decimals. like it. You guys are really into this. I love it. Okay. Positive. And so instead of t x equals A is negative 0.6, the B value is 37.2, the C value is negative 557. 5. I'm actually just going to do the whole discriminant all at once. 47.04 for the discriminant. Anybody? Just for the discriminant. I do number discriminant, so that means I can get answers. Uh-huh.
What is the discriminant?
The b squared minus 4ac, what's under the radical?
So will we solve that separately? Because I just put everything in it.
You can put it on your calculator.
Okay. Can we put it all over calculator for the test?
As long as you write this, you can go straight to an answer. There will be a question on the test specifically about the discriminant.
How do you get the square root of 47.04?
If I had to estimate it, the square root of 49 is 7. So I'm estimating it to be around 6.8, right? But I'm going to use a calculator to do it exactly.
You can estimate that.
No, you cannot. You need to use a calculator. Yeah, you can. It's just a lot harder. A lot more difficult. For time. I'm hearing some reports that some students got the same answer as me. I love that. So let's look at the words. The wordy words saying which year did it reach? So the model is showing 2 separate years, but this is talking about when did it initially reach that 800? When did it climb to 800? So we're taking the first one, not the second one. So this is years since 1980. So I'm going to say during the year 1995, 2005, 1980 plus 25. In the year 2005, the amount of nuclear energy generated reached 800 million kilowatt hour. Because it's 25 years after 1980.
I get how to do it.
That's great.
My bad.
I think I looked it up and it was like Australia had like the most nuclear energy generated. That's a lie? I don't know. Which country uses the most nuclear energy?
I don't know
Wait, Miss, you got Florida. You work for the FBI.
what. China.
I got a what? Yeah, I do have my handwriting. Yeah.
She is filming us.
I'm sorry.
Your last one has 27 views. Roger.
That would apply the first. It doesn't say in which year.
Einstein fell.
Alright, let's look at number 20. Yes, no, 39 and 40. Those were pretty tricky yesterday. Good challenge word problems. Page 239. 239.
Yesterday that it was so good. I thought I talked you out of that.
Page 239. And you were assigned to do 29 or 39 and 40. This is a lot to look at, so I've highlighted. So, for number 39, the function, and I think I wrote it for you guys. Negative 16t squared plus 35t plus 7. For the year, or for the height of 30, you get an imaginary answer, so the ball does not reach 30. For the height of 26, you get the answer 1 in 19 over 16, or 1.19. So the ball does reach 26 feet.
Oh,
Yes,
wait,
we
was
did.
was that like the actual questions or the examples?
No, this is number 39 that was assigned on these two, on this page.
You know what I did?
That was the whole equation.
I needed 40. I saw part B. I was like, what?
I did 12.
I understood that one. I just 40. I got your number. 3 seconds.
This is all number 39.
Okay. So I said it was 40.
So this is when 30 was plugged in, and this is when 26 was plugged in. Yeah, this is all number 39. You were to do it twice, once with the height of 30 and once with the height of 26. So this is both number 39. 40 is not up here yet.
Sean wasn't here yet.
Oh, okay. Yeah, they would
Yeah.
take a long word.
Beating up that.
No, he was on college first.
No, too busy. Zach.
He's gonna go to Manatee Technical College.
Oh my.
You said you might. Go to Manatee Technical College.
What
What do you think?
that sounds fun. At least you won. It's both. Playing later in the day though. Oh, real. Not enough here. That sounds boring as hell. It's fun song for the show. Yeah, but think about it. I think I saw that. Cheap boat. In fact, you snap.
There you go.
Nah, you shuffled it.
Yeah, for you.
If I do it, you gotta let me know.
No.
I don't think I'm gonna hockey.
I mean, there's
Oh, geez. What do you want?
oh, I didn't color that one in. Oh,
No, it's imaginary. Because no, imaginary. I think I could.
All right, let's go to 40. 40 was a similar setup. Go ahead and have a seat. Zachary, go ahead and have a seat. 40 was a similar setup, but instead of it talking about two different heights, it's talking about two different velocities. Your velocity is 105 feet per second, whereas the friend's velocity is 100 feet per second. So we weren't plugging in two different values for h. You're plugging in two different values for vertical velocity. For both of them, you set them equal to 200. This is the result of your velocity or your rocket. And then this is the result of your friend's rocket. Your rocket hits 200 feet, traveling 105 feet per second. Your friend's rocket doesn't quite make it. 100 feet per second wasn't enough propulsion to get that high.
the rocket was imaginary.
Oh, I remember talking about that yesterday. Was that this stuff?
Yeah. The rocket was imaginary.
Was it?
I don't think it was.
Someone was like, how was the distance imaginary?
I didn't finish it.
It really got me.
I didn't finish it in time to ask you that question. So listen.
All right.
I didn't know the rocket was imaginary.
Letter B was more difficult. Did anybody attempt letter B? Yeah. So letter B was talking about when does the rocket hit the ground? When a rocket hits the ground, it is at height 0. So you leave 0 in for h. You do the quadratic formula. You find that the longest time for either rocket was 6.84 seconds. I would just love to time a rocket. We should really want to do that. We really want to do
You
that.
know those weird the looking cone things on top of building 3536? I said we could get one of those off the roof and turn into a rocket. And we put a squirrel. We put a squirrel so you can.
You can make a rocket.
I hear you.
I want to put a squirrel into space and mark history.
All right, guys, let's move on. Does anybody want to ask a question about this?
What's the answer for the question?
For B, 6.84 seconds.
No, I didn't get that. I got like 2.9 and 2.7. But I plugged it in.
For yours, you left it at 0. And you did this whole formula. You should have got negative 0.27 and 6.
I don't want 7 because we're subtracting 30 by. I subtracted 30 by 200. I subtracted 30 by 200. You didn't have to subtract 1/7.
No, it just says when does it hit the ground.
Yeah, how I meant.
A ground question is height 0. Everybody turn to page 247.
Messed up, bro. Should have never went to college.
I guess that's
Well, now you gotta learn it in half a day.
Oh, you went to MTC? Did you love it? Was it your first time? What you didn't like it? Oh, was it? You ready? We're talking about systems. That means two equations and finding where those two equations cross. Before you guys did systems of two straight lines, linear systems. This is a system of non-linear equations. And that means at least one of the lines is non-linear. That is a vocabulary word on your next test. So look, we have a quadratic, and then we have a y equals mx plus b type equation, where you graph with an intercept and a slope. Now, graphing a quadratic, there's several strategies for, but you sure don't use slope. So we have a slope and then we have a parabola. There's lots of different ways this can look. Sometimes your line will never hit your parabola, which means it has no solution. Sometimes your line crosses in one place, like a tangent line with circles. Did you guys in geometry talk about a line touching a circle in one place? Yeah. Was it called a tangent? Yeah. I think so. Like that. Sometimes your line will go through like an arrow and hit your parabola with two real solutions. You could also have a nonlinear system with two parabolas. No solution, one solution, two solutions. Eventually, in algebra, not this year, but you might have something that's called a hyperbola, and then you might have a hyperbola crossed with a parabola. And in that situation, you would be finding four solutions. So systems of equations means there's more than one equation and you're finding where they cross. And it's just like a whole world of systems out there where sometimes you look at three equations and four equations. But what you're getting introduced to in Algebra 2 is possibly a line crossing a parabola or two parabolas crossing. All right, we are going to start with substitution. That's not it. I want to
Stop it.
7 and 8. 249. When would you like to move? It's the introduction to systems of linear equations. Are you ready to try a problem on page 249?
I got it.
It's okay. You can catch right up because all we're doing here is substitution, and you've done that before in your life. All right, you've done substitution before. You'll be all right. What we're going to substitute in here is we're going to take this y out, and we're going to substitute this entire expression in. We're going to find out where these lines cross. I'd love to just put it in Desmos. So we have negative 4x plus 8 equals negative x squared plus 4. And when we solve this, when we solve the equations mushed together into one, we will find the points that they intersect each other. How do we want to solve it? Well, it is a quadratic, so let's set it equal to 0. Let's set that equal to 0. So we did a substitute. And now we're going to set equal to 0. Does it factor? Did you try X factor yet? I'm tempted to. Oh, shoot.
I don't think it went. I just realized the real answer.
You guys, there's more than one right way to set it equal to 0. I'm going to add x squared over because I like a positive x squared. And that way maybe I can factor it. So I'm going to minus the 4. I'm supposed to write less. Here I am, writing a lot. Ooh, this might factor. Ooh, maybe I want to do the X factor method to solve this. It's A times C up here. So we're doing what multiplies to 4 and adds to negative 4. I think that works.
Make it sound tasty, bro.
Negative 2, negative 2. Yes, so this factors to be 1x minus 2 times 1x minus 2. I'll solve one of those, and I get x equals 2.
If you put it the other way, it's 8/4. There's no easy.
Don't do it the other way, bro.
You can x factor the other one. You do it right.
8/4.
Yeah, I don't. Let's talk. How do we get 8/4? Shouldn't you just still be doing 4 minus 8? Having negative 4?
But it's if you bring it on the 4 over.
It would be negative x squared plus 4x minus 4.
Oh yeah.
All right, don't stop. Find y. We're looking for a point that these two lines cross. So don't stop. Find y.
Solve one of those on top.
Yeah, yes. Which one do you want to do? Do you want to put 2 into the top equation or the bottom equation?
Bottom.
I like linear better. Let's put it right here. But if you want to put 2 right here, you can. It'll come out the same. It'll work either way.
High levels of intelligence.
Wow, you guys are so fast. Y equals 0. So the answer to this is 2 comma 0. Let's put it in decimals and check. It'll take you 2 seconds. So we're doing negative x squared plus 4, negative 4x plus 8. Fingers crossed, everybody. Fingers crossed.
Now it's not time to wash your teeth first. Yeah, that's why you just look up the sound.
You can start the next one if you're yeah.
You got my sled if you put a bar. Big dog. I can't do it.
Man, can we go next line?
Look what
On here.
Look at that, guys. It worked. So here's the parabola. It is opening down because it was negative x squared plus 4. Here's our points of intersection. Here's our straight line. And they connect right here at 2 comma 0, one place.
hold on.
Tangent line.
You would subtract the 5, so you're just to make that a 0.
You guys seem to really be buying into this. All right, let's do number 8.
Subtract 5, bro. Just put 2x plus 1 minus 5 equals 0. Watch. I'm gonna end up subtracting it. Watch.
Ooh, you're right. We have to get y alone.
Oh, wait. Oh, you gotta move the other one. I told you, bro.
But your instinct told you something was there. So now this y goes out, and I put this expression in. Ooh, this is getting a little more difficult already. X squared plus 3x minus 2x plus 5 equals 0. This is really fun for the people who like to do it. Loves algebra. X squared plus x plus 5 equals 0. Let's try x factor. Does anything multiply to 5 and add to 1? No. What are we going to do? Quadratic formula. Oh my gosh. Big reveal here. I have a negative discriminant. Am I wrong? Yeah.
Wait, I thought we were putting equal to each other.
Yeah, we did that on this one because they were both y equals. Now, really what I was doing is I was taking this y out and substituting this in. So here I take this y out and I substitute this in. Or you could move the y over and put it there. But it would be negative y.
Could I put like negative 2x plus 5 equals negative x squared minus 3x?
That's a main error.
Negative x squared minus 3x.
Yeah, negative 2x plus 5 equals negative x squared minus 3x. Like the first question.
I think you could. That sounds all right to me.
That's the solution.
Imaginary means these lines will not cross. These lines never cross. What kind of lines do we want to never cross? We never want flight paths to cross. We never want roads to cross without stop signs, right? If we're building roads for a city, let's make roads that don't cross. Let's shoot rockets that don't cross, unless we're trying to intercept a missile. We need those to cross. So that's military. That's military math. It's trying to figure out if a missile's on its way, how do you shoot your missile to make sure it hits it and stops it? So systems of equations, military warfare. Right there. That's it for me. I think I'm done. So the rest of your assignment, these two problems were required. The rest of your assignment is page 251. 7 through 10 is like multiple choice. And then you're going to have 3 of these to try, 19 to 21.
Good job.